So today we'll be solving for the electric force that these two particles exert on each other, the magnitude of that, and then we'll also be solving for the magnitude of the force that they exert on each other once they're connected with a conducting wire and once they're at equilibrium. So we do see that they are in nanocoulombs, so that's times 10 to the 9. And we have our formula right here, so this first part will just be plugging into that formula. So our electric force equals our Coulomb constant, which is 8.99 times 10 to the 9. And then we multiply that by the absolute value of our first charge, which is the 12 nanocoulombs to the 9, and then we'll also multiply on the top by the other charge, which is 18 nanocoulombs, and then we divide it all by the distance between them squared. So we'll do 0.295 squared. And when we do that operation, we should get 2.231 times 10 to the negative 5. And this is our first answer. And for the second part, when they're connected with a conducting wire, that means that their charges will equal out. So our total charge, so we have the 12 charge, and then we have the 18. So in total, the amount of charge, not counting if it's positive or negative, we have 30. And once they are at equilibrium, that means they will both have the same charge, so we gotta half that, and then we get our charge to equal 15. And then we don't forget about the nanocoulomb. And so from here we can kind of change our electric force formula just to have the constant there, and then we can just change that to q squared, and then it's still over distance squared. And when we start plugging in our numbers, we should get our electric force equals 0.99 times 10 to the 9. And then our q we have is right here, so it's 15 times 10 to the 9. And then it's all squared. And then it's all divided by the distance, which is still 0.295 squared. And then once we do the calculations for that, we should get 2.324 times 10 to the negative 5. And that is our answer for the second part of the problem. And we are just looking for magnitude.